I want to spend just a little bit of time talking about prime factorization so that I might be able to find the square root of 108 or the cubed root of 108 a little bit easier. Okay, prime factorization, I'm just going to write 108. I'm going to write all the factors of 108 that are prime. So I'm going to start with 2 just because it's easy. 2 goes into 108 54 times. Okay, 54 is not prime, so I keep on going. 2 goes into 54 27 times. Well, 27 is not prime. I keep on going, but 2 doesn't go into 27. What's a prime number that goes into 27? 3. 3 goes into 27 9 times. 9's not prime. Keep on going. 3 goes into 9 3 times. I get a prime number here, so I stop. So now thinking about the squared root of 108, well, the index of the square root of 108 is 2. We don't see the index of 2. You don't see the index of 2 written often, so if you don't see an index for a root, just know it's the squared root. Since the index was 2, I'm looking for something that repeats twice. Well, the number 2 repeats twice, and the number 3 repeats twice. So the answer to the squared root of 108, you would bring a 2 out once because it repeated twice. You would bring a 3 out once because it repeated twice. And then this 3 right here that was not a part of a group, it remained. It will remain on the inside since it wasn't a part of a group. So the answer to the squared root of 108 is 6 square roots of 3. For the cubed root of 108, we're looking for something that repeats 3 times. So, okay, 2 repeated twice, but ironically 3 repeats 3 times. Okay, so since 3 repeated 3 times, it comes out once, and then this 2 was not a part of a group of 3, and that 2 was not a part of a group of 3. So they have to remain on the inside. And the answer is 3 cubed roots of 4. So let's get really crazy for a second and ask ourselves, what would be the fourth root of 108? Since I've done the prime factorization of 108, I can answer that. And it is just the fourth root of 108. The reason being is because none of those prime numbers repeat 4 times. 2, 2, 3, 3, 3. There's not a repetition of 4. So it's already simplified. The fourth root of 108 is not simplified. The same thing with the fifth root of 108. Nothing repeats 5 times. We could go on forever talking about this. Let's do another example. Let's do 32. We're going to write the prime factorization of 32 so that we might find the square root of 32 and the cubed root of 32 a little bit easier. So I'm going to take 32 and I'm going to divide it by prime numbers. I want to list all the factors, all the prime factors of 32. So 2 goes into 32 16 times, and 2 goes into 16 8 times. I keep on going because 8 is not prime. 2 goes into 8 4 times, and 2 goes into 4 2 times. Okay, so with the squared root of 32, I'm looking for groups of 2. Here's a group of 2, and here's a group of 2. So the answer is we had one group of 2 and another group of 2, so it came out twice for group 1 and group 2. Okay, and then this 2 was not a part of a group, so we have to, it remained, so we have to leave it on the inside. It has to remain on the inside. So the final answer here is 2 times 2 is 4 square roots of 2. So with the third root of 32, I'm looking for groups of 3. So here's a group of 3, and then we have 2, a second 2, but not a third 2. So there was only one group of 3. So the answer here, we had one group of 3. Um, uh, so we bring that 2 out one time. And then this 2 and this 2 were not a part of a group. So those both remain on the inside. So the answer here would be 2 cubed roots of 4. And just because we can, let's go ahead and do the 4th and the 5th root of 32. So for the 4th root, we are looking for a group of 4. So I have a group of 4, one group of 4, so that 2 can come out once since there was one group, and I just have 1 2 left that remains that is not a part of a group, so that 2 can remain on the inside. So the 4th root of 32 is 2 fourth roots of 2. And now for the 5th root, we see that we have 1 2 3 4 5. We have a group of 5. So that 2 can come out one time since there was one group of 5, and you see that nothing remains. So nothing stays on the inside, and that's why if we typed in our calculator the 5th root of 32, the answer would just be 2. So let's do one more. We'll do 540. We'll list the prime factorization of 540 so that we may find the square root of 540 and the cubed root of 540 just a little bit easier. So I'm going to divide 540 by prime numbers and keep on dividing it by prime numbers until I end up with a prime number. I'm going to do a little bit like this. So 540, I'm going to start out with 2 because I know 540 is even. Therefore, if it's even, 2 goes into it. And so 540 divided by 2 is 270. 2 still goes into 270 because 270 is even. And 270 divided by 2 is 135. And I don't think 2 goes into 135, but it ends in a 5, so 5 goes into it. 5 goes into 135 27 times. 27 is not prime, so I keep on going. 5 doesn't go into 27, but 3 does. 9 times. 9's not prime, keep on going. 3 goes into 9 3 times, and I ended right here with the prime number, so I can stop. So with the square root of 540, I am looking for groups of 2, and I have a group of 2 right here, and a group of 2 right here. So 2 repeated twice, it comes out once. 3 repeated twice, it comes out once. And then this 3 and this 5 did not repeat twice. It is not a part of a group. So they both remain on the inside. So the answer to the square root of 540 would be 6 square roots of 15. Now for the cubed root, I'm looking for groups of 3, and I see one right here. But then there's not another group of 3 of a number that repeats 3 times. So the number 3 can come out because it repeated 3 times. And then 5 did not repeat 3 times. 2 did not repeat 3 times, and this 2 did not repeat. So those can all go back on the inside because they remained. So the answer here is 3 cubed roots of 20.